Hi everyone, welcome back to another Stemly math tutorial. Today we'll be discussing the product rule. We've got three examples. Let's get into it. So say we have some function y equals x squared plus sine of x, and we needed to find the derivative. We can do that by using the addition rule. So we take the derivative of each term. So x squared becomes 2x. Sorry, I'll fix that one up. 2x. And then plus the derivative of the second term, which becomes cosine of x. All right, that's simple using the addition rule. But what if this term here, the addition was a multiplication sign? Let's write that out. So y equals x squared multiplied by sine of x. We no longer can use the addition rule, and that's where the product rule comes in. We have two notations for this one. We got the Newtonian notation, which is the one I will be using mostly, but they're both identical. So for some function y equals uv, the derivative equals y dash equals u dash v plus v dash u. And then for the Leibniz notation, I think that's how you spell it, you have your operator, so the derivative of then your function, so uv equals your u multiplied by the derivative of u, multiplied derivative of v with respect to x plus your v multiplied by the derivative of u with respect to x. These videos, we'll be using this one. All right, so let's go back to our original example. So say we have y equals x squared sine x, with these two functions being multiplied by each other. Now we need, according to this, we need a u and a v. So let's let u equal x squared and then v equal sine of x. Now we need our u dash and v dash. These are simply the derivatives of u and v respectively. So u dash equals 2x and v dash equals cosine x. Now we have everything, we can just plug it straight into the formula. So y dash equals, so we have u, so we need our u dash, which is here, so 2x v, which is our sine x, times sine x, now plus, and then v dash, cosine x, and then a u, which is x squared. There you have it, that one's complete. We'll move on to another example here, so we can get some more practice. So say we have some function y equals e to the x cosine of x. All right, again, we can't use the addition rule because we have two functions multiplying by each other. So we got x squared, so x e to the x, and we got cosine x. Okay, so we write down our formula. Y dash equals u dash v plus v dash u. All right, now we make our allocation. So let u equal, let's go e to the x, and then v equal cos of x. And these can be whichever way, it doesn't matter. Now we need our u dash, which is the derivative of u, so u dash, and the derivative of e to the x is simply e to the x. That one doesn't change, that's a special case. And then we've got v dash, so v dash equals the derivative of v, which is negative sine of x. All right, now we've got everything we need to put it together. So y dash equals u dash, which is e to the x, multiplied by v cos of x, plus, now we have v dash, which is negative sine of x multiplied by u, which is also e to the x. All right, now we just do some little rearrangements. Equals e to the x cosine of x. And then we just pull this one at the front with the negative. So negative e to the x sine of x. And there we have it. We'll try one with Leibniz notation as well. So say we have, we'll write down the formula. So d on dx, that's our operator, saying take the derivative of u v equals, so we need u multiplied by dv dx, so the derivative of v with respect to x, plus v multiplied by the derivative of u with respect to x. Okay, now let's apply that to this function. Let y equal x squared ln of x, so the natural log. Okay, so identify our two functions. So we got x squared and ln of x. All right, let's go. Let u equal x squared and v equal ln of x. Again, we need our u dash, which is the derivative of u, which equals 2x. And then we need our b dash, which is the derivative of v. And the derivative of ln of x is simply 1 over x. Okay, now we have everything. We can plug it straight into our formula. So y dash equals u x squared. And then we have a derivative of v with respect to x. This is our v, and we differentiate it with respect to x. So that's our v dash. So times 1 over x. Now plus, and our v, so we need v ln of x multiplied by the derivative of u, so we have u, and we need the derivative with respect to x, and that's what we got here, so times 2x. All right, now we've got some simplification, so y dash equals x squared over x plus 2x ln of x. All right, and we can simplify this one down to just x. Y dash equals x plus 2x ln of x. And that's done.